Problem 17 and 18 ask us to find the derivative of an unknown function, dr dt. So the unknown function this time is revenue as a function of time. I don't know what that is, but I can figure out the change in revenue over time by using the chain rule. So look what I have. I have r as a function of x, and I have x as a function of t. So if I want dr dt, I'm going to take dr dx and multiply it by dx dt, and make sure at the end of the problem I have no variables other than t present. So dr dx, that's going to be 6x plus 2 dx, oops, sorry, go back, plus 2, and then dx dt will just be 20. Alright, so I can't have that x there, so I'm going to replace that with 20t. 6 times 20t plus 2, well in parentheses, times 20. Okay, let's go one more step, or maybe two more steps. So I have 120t plus 2 times 20. So what do I want to do there? I might as well just multiply that out, right? So 20 times 120, whoops, sorry, go back. 20 times 120 is just 2400t plus 40. Okay, if I wanted to, I could make these factors, which is always a good idea. So my final answer would be factor out of 40, and then I would have 60t plus 1, and that is dr dt. Okay, so let me put a little line here so that I can work on the next problem, and I'll change color just so you can tell the difference. Okay, so same idea here. I'm looking for dr dt, and I'm going to be able to get it by doing the chain rule, get dr dx and multiply that by dx dt, and replace all of my x's with t's by using the function. So dr dx is going to be 2x minus 2, all of that times 12. Okay, wherever I have an x, which is right here, I'm going to put in a 12t instead, minus 2. Okay, then be careful about this step. All of those terms are multiplied by 12. So clean up inside the parentheses. That's 24t minus 2, and then that whole thing times 12. Okay, so what am I going to get? Well, 12 times 24 should be getting me 288t minus 12 times 2 is 24. So let me just check on my math for a sec. Okay, everything looks good. So 2 times 12 is 24. Now, I can factor out 24 goes into both of these terms. So I'm going to end up saying that dr dt equals, pull out a 24. 24 times 12 gives you back 288. T minus 1. And that's your best form for this answer. Okay, so those are dr dt's. Let's go on the next page and we'll do the last two problems. Okay, so we didn't really teach this per se, but you do know that the area of a rectangle, just a plain old rectangle, is, if I call this the length and this the width, area is just length times width. So what happens if length and width are a function of time? Area then also is a function of time. So you're going to have to introduce the product rule. So let's see how we're going to do this. If I know that area equals length, which is a function of time, times width, that's a function of time, that automatically makes, let me just make this clearer over here, that makes my area a function of time as well. So things are changing. So let's read the problem and see what data they're giving us. So it says, find the change in the area of a rectangle with respect to time, given length and width are functions of time. All right, so that sounds good. So they're telling us to use a product rule, and then we have functions. So it looks to me like I'm not going to get an answer for this one. I'm going to get an expression. So let's see if we can figure it out. Since they're both functions of time, so they're both derivatives, so we're going to say left, and left is the length, LT squared, minus 7t, d right, and d right is just 4t plus 5, plus right, so 2t squared plus 5t, d left, and that's going to be, what, 6t minus 7. Okay, so we're going to have to clean this up a little bit. So I believe what I did was FOILed everything. And I need my parentheses here. Okay, so now, and this was A prime. Having little stylus issues again. I'm going to say that's A prime, and there you go. Okay, so A prime t, if we FOIL, we're going to get 12t cubed minus 28t squared plus 15t squared minus 35t. Okay, that's our first expression. And then plus, I'm going to do another FOIL. So I have 12t cubed plus 30t squared minus 14t squared minus 35t. So I have to add both of those together. So let's see what we have. We're going to go from left to right and bring all these terms together. So how many cubic terms do I have? I just have 2. They are both positive, so that makes that 24t cubed. Those are done. Okay, so then I have a negative 28t squared plus a 15t squared minus a 14t squared plus a 30t squared. Okay, so let's add these together. So negative 28t squared and positive 30t squared so far gives me a 2t squared. So those two are taken care of. Now I have a 15, so plus 15 plus or minus 14, so that's just plus 1 more. So it looks like all I have is a plus 3t squared. Good. Now I don't need this over here. Alright, so then we've now taken care of the t squares. So look at the t's and see what we have. We have a negative 35t and another negative 35t. So that's going to be minus 70t. Okay, so here is an expression for how area is changing over time given the two area functions we've dealt with. Alright, so that's an answer that we can leave the way it is. You can factor out a t, but really it's not going to help us that much. Alright, next one, number 20. We're going to get a simpler answer because I'm not giving you as complicated functions, and I'm actually giving you some values to work with. So let's do that on the next page. Okay, so let's read this problem and write down things as we go. So it says the width of a rectangle is increasing at a rate of 4 inches per second. So the width, so W prime equals 3 inches per second. It's telling me how it's changing. And its length is increasing, so its length is also increasing at a rate of 4 inches per second. So that's 4 inches per second. So that's length, so that's L prime. Okay, so this is going to be 4 inches per second. So at what rate is the area of the rectangle increasing when its width equals 5 and its length equals 6? And then I say, hint, let WT and LT be the widths and lengths respectively at time t, and recognize that you have been given the derivatives of each, and yes, we have. Notice also, I've used the word increasing. If I said it was decreasing, both of those would have been negative values. That's important to know. Okay, so let's start out. Area equals length times width, but all three of these are functions. So area prime equals left d right plus right d left. Okay, so what's happening there? Do I have values I can plug in? Well, length is 6. W prime is 3. We're not going to worry about units yet. Plus width is 5. And L prime is 4. So if I do those, then I'm going to get the following. This is going to be 18 plus 5 times 4 is 20. So I will get 38 inches squared per second. Okay, now I want you really to take note of whether the problems say increasing or decreasing, because if they say decreasing, then these derivatives are going to change their sign. So watch out for that. This is the last problem, so you should be able to think this through and apply it if you have information presented a little bit differently about the area. So what I've learned is that my rectangle, given the changes that are happening, is growing at a rate of 38 inches squared per second. So it's really getting big. So this is the last problem. I hope you found this helpful.